All right, so today we have 3-4 synthetic division. Long division, which you just saw the lesson on yesterday, it's kind of rough for a lot of kids. If we're dividing by what we call a linear factor, linear factors are things that look like mx plus b, okay? But they're very simple forms, like maybe just x minus 4. We can use what's called synthetic division. I'm not going to go into why it works on this video. If you want to know, I can tell you. Maybe it's been a while since I've sat down and done it. But anyways, it's a whole lot different, but it's far easier. So we're going to divide 2x cubed plus x squared minus x plus 5 by x plus 3. Now, what we do is we think about x plus 3 as a potential 0. And if it's a potential 0, we could say this: x plus 3 is 0. We're just going to subtract the 3 and we have an x value of negative 3. We're going to have an upside down vinculum that's 2 stories tall, and we're going to put the x value there. That's x, and x was negative 3. We're going to keep only the coefficients. And we're going to drop the first term, which is the 2, and then we're going to multiply. Negative 3 times 2 is negative 6. And then we're going to add until we reach the end. So 1 plus a negative 6 is negative 5. Negative 3 times negative 5 is 15. Negative 1 plus 15 is 14. And negative 3 times 14 is negative 42. And then we add 5 and negative 42 and we get negative 37. Weird, huh? This is the remainder. Preceded by a remainder is a constant, preceded by a constant is an x, and preceded by an x is an x squared. And that pattern continues as you move left. It's just how it works. So what I have here is I have 2x squared minus 5x plus 14. This is what we call the quotient. I don't know if you remember the quotient or not, but it's the stuff left over after you do division. Plus the remainder, which is a negative 37 pieces of the original divisor, x plus 3. And I have an acronym for it, DMA. The bar over the MA is multiply and add, because you do that until you're done. All right, let's move forward. If f of negative 1 is 0, what do we know? You are told f of 4 is 0. Use this to completely factor the polynomial 3x cubed minus 4x squared minus 28x minus 16. So what I'm told here is I'm told that x equals 4 is a 0. Now this also means x minus 4 is a factor. Let's start off with this piece right here, that x is 4. We'll throw that out in front of the vinculum. We'll put our coefficients on the second floor. And then we will drop. Remember the acronym is DMA. We will drop. We will multiply. We will add. We will multiply. We will add. And we will multiply. And we will add. And I got a remainder of 0. Preceded by a remainder is a constant. Preceded by a constant is an x. And preceded by an x is an x squared. That's how it works. This just reminded me, I never did a video for the 3-3 lesson. I guess that's what I'm doing next. All right, so since I don't have a remainder, the quotient is 3x squared plus 8x plus 4. And the goal was to completely factor this polynomial. So I should be looking at this thing and saying, hey, does this FOIL? And you know what it does? It takes a 3x and an x to make a 3x squared. Factors of 4, my gut says 2 and 2. And it works because 2 times 3x is 6x, 2 times x is 2x, and 6x and 2x makes 8x. They're both positive. And all I got to do is bring in that missing factor right there, and I'm in business. That is the complete factorization of that cubic. It also could have been done with factoring by grouping. I didn't talk about remainder theorem, but it's okay. Factor 3x cubed minus 4x squared minus 28x minus 16. Given that f of negative 2 is 0. So again, this means that x is negative 2. And it also means that x plus 2 is a factor. Go ahead and put that in parentheses. Make it look more like the factors you're accustomed to. All right, so let's do the same thing we've been doing. Put that x value out front. And then we drop. Remember the acronym DMA, drop. Multiply, negative 2 times 3 is negative 6. Add, negative 4, negative 6 is negative 10. You know, it's the multiplication and addition that gives kids problems. A negative times negative is positive. 2 times 10 is 20. We add, we get negative 8. 2 times 8 is 16. Negative times negative is positive, and such forth. And there we go. And again, remainder, constant, x squared. That's how it works. 3x squared minus 10x minus 8. Does this thing factor? You betcha. It does. So to make an 8, it's probably going to be a 2 and a 4. The outside's going to make 12. The inside's going to make 2. A negative 12 plus 2 is the negative 10 in the middle. And again, let's bring down this other factor that we found earlier and just put it right in front or in the back. It doesn't matter where it goes. But that's the complete factorization of that polynomial. All right, this one is unique in that we have to use what's called placeholders. There's a big jump from x cubed all the way to the constant, and synthetic division requires those placeholders be there. Most kids figure this out, so we need an x squared, we need an x, and then we can have our negative 8. Now, I don't know why it doesn't say that, but it is a factor. Okay, so x minus 2/3 is a factor, which means x minus 2/3 is a 0, which means that x is 2/3. So we're going to put a positive 2/3 out there. We're going to drop the 27. 2 times 27 is 54, divided by 3. Actually, I should divide by 3 first. Anyways, it's 18. 0 plus 18 is 18. 2/3 of 18, that's going to be 12. I add. And guess what 2/3 of 12 is? Just guess. It's 8. That's what it is. And you put those together, you get a 0. So what are we left with here? We're left with this funny looking thing. Remainder constant x squared, which is 27x squared plus 18x plus 12. Now, this factor is just a touch. It doesn't factor much. All three of those things are divisible by 3. And leave me with 9x squared plus 6x plus 4. And I also had the x minus 2/3 there. I'm going to go ahead and put that in there. And I'm going to show you why this piece doesn't factor anymore. Or does it? No, it doesn't. I'm going to have 3x minus 2. And then I have this piece right here, 9x squared plus 6x plus 4. Now, this is actually a problem from a previous lesson, 3.3. And, well, here's the deal. This piece doesn't factor. And I doubt you remember yesterday, but this is a 3x that's cubed minus a 2 that's cubed. This is the a cubed minus b cubed pattern, which is a minus b times a squared plus ab plus b squared. And this piece does not factor, at least nicely, because everything there is imaginary. Now, we will do a lesson where we factor over the complex number system, but this is the complete correct factorization of this polynomial. All right, we are given an expression for the volume of a rectangular prism. Find an expression for the missing dimension. I'm going to pause real quick. BRB. I feel like if I remember these notes when I made them, what's in this box says synthetic division can be done multiple times. It can be. Will you do it right? I don't know, but it can be done multiple times. We're going to treat these, and I've talked about this in class with y'all, we're going to treat these as factors because this times this times this would equal that. So x plus 2 is a 0. It's a factor, which means x is -2. I'm just going to start with that one. Doesn't look like I need any placeholders. I got a 2, a 17, a 46, and a 40. I'm going to drop the 2. -2 times 2 is -4. 17 plus a -4 is 13. -2 times 13 is -26. 46 plus -26 is 20. -2 times 20 is -40. 0 for remainder. Now, if you get a 0, just use the new numbers. That's about the best way I can say it. So I'm just going to continue on. I'm going to draw another vinculum. And this time I'm going to look at this guy. This guy would say x is -4. Just change signs. I've talked about that repetitively with y'all. You just don't want to believe it. -4 times 2 is -8. 13 minus 8 is 5. -4 times 5 is -20. And by golly gee, wow, I got a 0. Remainder constant x. This is the last factor. It's 2x plus 5. That is the missing length. She is 2x plus 5. If I had some time, and you know what, since it's a video and not class time, let's just prove this is right. So let's take x plus 4 and x plus 2 and then 2x plus 5 and see if we get the original polynomial. So if I was to FOIL this out, I'd have x squared plus 2x plus 6x plus 8, and then I would still have the 2x plus 5 that I have to work with. I know y'all don't like the box method. X squared times 2x is 2x cubed. 2x times 6x is 12x squared. 8 times 2x is 16x. X squared times 5 is 5x squared. 6x times 5 is 30x. And then 8 times 5 is 40. So there's your 40. 30x and 16x makes 46x. 5x squared and 12x squared makes 17x squared, and then 2x cubed. It was the missing factor. It was. All right. You are told that x squared minus 4 is a factor of x squared plus 12x squared minus 64. Use that fact to completely factor f of x over the complex number system. Evidently, I haven't changed these notes. By the time I do this in class, that doesn't need to say that. What is the complex number system? The complex number system is the set of both real and imaginary numbers. It's everything. It's all numbers, whether they are real or not. Now, x squared minus 4 is kind of special. X squared minus 4 is a pattern that hopefully most of you guys have figured out. It would factor as x minus 2 times x plus 2 because it's what we call a difference of two squares. And I know a lot of you this year will not because you cheated your way through Algebra 1 with the Goth app. And that's a you problem. That's not a Milbrath problem. I swear it's not. So anywho, let's see what we got here. Of course, you could just look at that and factor it if you knew how to factor. Let's see, I have an x to the 4th. I don't have any x cubes. I have a 12. I don't have any x's, and I have a -64. Placeholders are a big deal. They are. They're actually a really big deal. I'm going to drop the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 12 plus 4 is 16. 2 times 16 is 32. 0 plus 32 is 32. 2 times 32 is 64. All right. I got a 0, which means that I get to do this whole process again. This time I'm going to use the -2. I'm going to drop. I'm going to multiply. I don't know why I put a 0 there. I'm going to add -0. I'm going to multiply. I'm going to add. I'm going to multiply. And I'm going to add. And I'm left with the remainder, a constant, an x, and an x squared. I'm left with x squared plus 16. Now, how does that factor? This is probably the easiest way for most of y'all to learn how these things factor. Set it equal to 0. X squared would then be a -16. X would be plus or minus the root of a -16, which is going to be plus or minus the imaginary root of a +16, which is plus or minus 4i. Now, at this point in time, with the way everything has been scaffolded to you, you should be able to realize that if I have an x value, I can create a factor. All right? I can't. See how 2 was a 0, negative 2 was a factor, negative 2 was a 0, positive 2 was a factor. So what I've learned so far is that the two real factors are x minus 2 and x plus 2. And now I'm going to introduce these things. If x equals 4i is a 0, then x minus 4i is a factor, and vice versa. That's the complete factorization of that polynomial over the real number system. And moving forward, and I'm done. Sweet. Bad news is I realize I didn't do today's lesson. Bummer.